It's a pleasure to talk about a topic that is near and dear to my heart, and hopefully to share some interesting insights with you. The slides have a lot of information, and I will only hit the high points, but I always think it's fun for you to know that there's a lot of work that goes behind each of the ideas. So for the last 35 years, I've been enchanted with the idea that stress causes reproductive function and have wanted to know some of the mechanisms. So I'm going to talk about how energy balance plays a role in reproduction, but also to talk about psychogenic stressors and to talk about stress sensitivity. Now, you can actually see a great example of stress sensitivity here today because some people are much more tolerant of the heat than are others, and that is actually a very important source of stress in many parts of the world. Why care? Infertility is one reason to care, but there's more than that. I know that Dr. Chalice is going to talk about preterm labor. There's the fetal origins of adult disease. Even obesity and cardiovascular disease have as components a stress etiology. I also want to talk about intervention. So we have pioneered the use of cognitive behavior therapy as a method to deal with stress-induced anovulation. So there are many health consequences of stress. I've just reviewed a few, and there are many mechanisms that mediate stress. And I'm not going to be able to talk about all of them today, but this is kind of a grand slide to talk about stress as unrelenting, unpredictable, and unresolvable. The neurobehavioral response to stressors, and then some of the what you might call health outcomes of stress are listed below. And I will just focus on reproductive compromise today. So when talking about reproduction, one must talk about metabolism, as well as social and psychogenic stressors. And there are some cognitive features that increase sensitivity to psychogenic stressors. Some of them you may be familiar with. One is lack of control. We sometimes call that social subordination. Perfectionism, which is its own stressor. The need for social approval. External locus of control is what I sometimes call that. And overly high expectations of self and others. Some of you may recognize some of those stressors. Actually, the last thing Wiley ever said to me is that he liked this editorial. So in the name of Wiley, who actually was the progenitor for me meeting Felice, all things were put together by Wiley, and I think that's one of the themes today. So what does stress-induced anovulation look like? So the core of it is to see the beautiful GnRH pulse generator slow down to the point that it doesn't drive the reproductive system. And when that happens, two other things always happen. There's a reduction in thyroid and an increase in cortisol. So all of those three things always travel together. It may be difficult sometimes to see them travel together, but they are always there. This is a beautiful study done by Anne Laux, who reduced energy in ovulatory women to a very extreme amount, say 80% reduction. And when she did that, there was a slowing of LH pulses, which Bill has explained earlier, is a good surrogate for GnRH pulsatility, which is a good surrogate for reproductive drive. And when that happened, there was an increase in cortisol and a decrease in glucose in the circulation. So the systems are integrated and they respond as a group. Now, why would metabolism be so important for reproduction? So I've spent several hours preparing this slide one day. I actually wanted to calculate how much energy is required for pregnancy and lactation. And what inspired me to look at that was the simple last line that it took 13 million calories to raise a human from birth to maturity. Now, how many of you have provisioned 13 million calories to some young person who's now ambulatory and self-sufficient? It was a long pathway. And so we have to have enough energy to get through pregnancy. So for that to happen, we have to have enough energy to ovulate and to make gametes. So it makes sense that there would be a tight link. And the tissue most dependent on calories is the brain. I think it's a Lamborghini. It's a race car, right? It's a fuel hog. So the brain is the most expensive tissue in the body to run. It's 2% by weight, and 25% by 25% by oxygen consumption. So it's a very expensive tissue. And so the brain would notice if it were underfueled or underfed. And of course, we've just studied the tip of the iceberg. I don't have time to go through all of this today, but I noticed in the monograph that's being handed outside, which is an Italian population study, that stress is listed as the #1 cause of infertility in Italy. So I thought that was interesting. And I accounted for in the population summary out back for 30%. Well, that's pretty large. It is a diagnosis of exclusion. I always say this, but I had to actually live by this just recently. A woman came in and gave a classic history of stress. She was a physician, and she'd been sued, and made sense that her life was falling apart, and she was suddenly amenorrheic for the first time in her life, and she'd been pregnant before. So just to be complete, I measured a testosterone level, and it was male level, and she turned out to have an adrenal rest tumor that I assume was activated by stress. So I'm going to write that up as another cause of stress-induced anovulation, but I wouldn't expect you to see too much of it. So Richard Reindaler, who's now working at ASRM, actually did this study a long time ago in Georgia when he was a fellow or junior faculty, and looked at the causes of amenorrhea. And one could easily, I think, say that hypothalamic amenorrhea, including the functional forms, is a very common, if not the most common form. And of course, Bill introduced the genetic causes of HA today, which is an incredible contribution. I study the ones that I hope just have stress as the cause, but one can never be sure. And stress, when I was introduced to it, had this little paradigm behind it. This is what we worked out in San Diego with Felice and Wiley and Sam Yen and a crowd of people that contributed to this concept. And this was the conventional dictum. And we've been working on this to see if it was true. So we looked under 3 categories: neurobiological factors, metabolic factors, and psychogenic variables. And I'm going to tell you briefly about each. So one thing we know is as cortisol rises, the LH pulse frequency decreases. So that simple little fact is something to put in your mind to remember how this works. And it's the same in men and women, although the stressors to which men are sensitive differ from the stressors to which women are sensitive. And this is a beautiful study done in part by Benedetta Brundu, who is a fellow sent to me by Rosella Nappi, who's sitting in the back. And what we did here is to ask a simple question. So he had seen that in the CSF, so these were 25 ml of CSF that was withdrawn from the lumbar compartment, and we took the top 5 ml and measured ligands of interest. And the first one we measured was CRH, and it was the same, even though we knew the women had elevated cortisol levels. So we were confused, and we measured then cortisol in the CSF. And while the circulating cortisol is around 20 to 25% higher and difficult to detect if you do not do frequent sampling, in the CSF, with a single sample at a single time point, there's a 30% increase. So we developed the concept that the nerve axis uniquely sees the stress signal. And it will be difficult assaying the peripheral compartment to actually understand how much stress the brain is seeing. Part of that is because the peripheral circulation has a compensatory mechanism that's somewhat demonstrated over here. So as cortisol rises in the circulation, the liver makes CBG to bind it, and so the free fraction will actually be the same, and I think that's why they don't look cushienoid. So here you can see in the circulation it's somewhat elevated, in the CSF more elevated, and yet when you looked at the free cortisol, in the circulation it's not elevated, and we don't have binding proteins to the same extent in the CSF, so that's the free fraction. So the brain uniquely is seeing the stress signal even when the periphery is not seeing it so much. And when you think about the downstream consequences, I want you to think about the brain as the target. So one thing that happens also when you have this group of individuals who have amenorrhea, and we only study those who are normal body weight, so nobody with a known psychiatric disorder and no one with a known eating disorder, you can see that T3 is remarkably suppressed and TSH is not elevated as it should be. So that's what we call hypothalamic hypothyroidism. And it's as if the brain does not care. So we call this allostasis in Bruce McEwen's lingo. And basically, the hypothalamic pituitary ovarian axis is insensitive to the fact that the ovary is not ovulating. Brain notified and doesn't care. The HPA axis, the cortisol is elevated. You would think the CRH would then go lower so that the cortisol could come back down. Brain notified and likes that high cortisol, so it must be serving some purpose for it. And same for the thyroid. The T3 and T4 are reduced, and the TSH does not increase to bring the thyroid back to range. So this is clearly a CNS event. And we also think it alters the response to appetite signaling. I don't have time to go into much of that now, but that's what I've been working on more recently, is to understand how stress alters our appetite. So, summary, stress causes suppression of GnRH drive and secondary anovulation and hypoestrogenism, and that's the most profound form of it, and it comes in other shades of gray. There's an increase in CRH drive and a secondary hypercortisolism that actually most impacts the brain. There's a reduction in T3 and T4 that is not compensated for by a decrease in TRH. And there's altered appetite signaling and responses to appetite signaling. And the responses to that will vary depending on the fuel environment one finds one in. And we have monkey studies to look at this. But basically, if there's a lot of food around and you're stressed, most people tend to eat. And if there's not so much food around and you're stressed, you have an increased metabolic demand and you can't keep up with it. So we have used a monkey model of social subordination to study some of this. I don't have time to go into all of the monkey model right now, but I wanted to share one little piece of it today. So we had monkeys that we stressed, had to do something that was approvable. So one of the stresses was to train them to run 2 miles a day on a treadmill, something that many people do electively, and the monkeys didn't mind. They ran to the treadmill and ran. We actually had to pull them off, just like some humans. We actually gave them a small reduction in calories, and then we also gave them a move. That was the social stress. So imagine that every day of the week you had to go home to a new home. In work, and you don't know where you're going. That's what we did to the monkeys. It's a pretty benign stress. So when we just gave them the diet plus exercise challenge, about 10% of them became transiently amenorrheic. When we gave them the move, 10%, and when we combined those two, a whopping 75% or 70% of them became transiently amenorrheic. So what this shows you is seemingly minor stressors that you really wouldn't identify necessarily as a stressor can be more than additive and synergistic. And so when women walk in the office and they say, I really don't know, I have nothing really big to report, they're usually telling the truth. You have to actually help them identify what the seemingly small stressors are that may be bothering them. So one of the ways you can understand how stress works is shown here. So this is a human model of that same concept. So we took women who were amenorrheic, normal body weight, and gave them an exercise challenge to 70% of VO2 max. And in normal individuals, which are shown on this side right here, glucose rises to meet the energy demands of exercising. And those who are amenorrheic, for whatever reason, they can't keep up with the metabolic demand and their glucose declines. There's always a cortisol rise in response to exercise, but it's a bigger cortisol rise in people who are already having an elevation. So some people think that stress is good for stress management, and we would argue based on this that one would be wary to use this as an intervention for stress management. So a simple cartoon to summarize some complex ideas and some data that took many years to elaborate is that metabolic imbalance synergizes with psychogenic challenge to suppress the gonadal axis, activate the hypothalamic pituitary adrenal axis, and suppress the thyroidal axis. It's the combined integrated constellation of changes. So this brings us back to the GnRH pulse generator, my favorite part in the body. and to understand what are some of the signals that mediate the offset of the GnRH pulses. Why would they go from 1 every 90 minutes to 1 every 2 to 3 hours? They don't go all the way off, typically. So what's modulating that? And so to understand that neural network of GnRH neurons, a lot of different substances have been looked at across many years. And we don't have time to go through all of it, but it's getting increasingly complicated to understand. And I just want to point out one of the ones that we're interested in right now is an integration station, is GABA, and this accounts for some of the more recent candidates, including kisspeptin and the KNDy neurons that are shown here. And a lot of this neuromodulation apparently occurs in the median eminence. So even the GABAergic neurons may be a target for leptin, and I want to show you some interesting data that we have in the patients that we've treated and looking at some of this. So if we assume, just for the moment, that GABA is an integration station above the level of the hypothalamus and the signaling to the hypothalamus, we can look at all the different inputs that might modulate it. And to try to look at this and to understand how stress, which is also being modulated above the level in part of the hypothalamus at the hippocampal level, we did a wonderful study, and this is also an ode to San Diego and the SALT group. So this is A stress in B, which is Jean Revier's CRH antagonist. This is a very complicated study. It's done in monkeys. It just was released in Neuroscience last year, or almost a year and a half ago now. So this is a region of interest analysis looking at the brain and looking at GABAergic binding in the brain using neuroimaging. And basically what we were able to show is at the level of the hippocampus that giving a CRH antagonist changes GABAergic binding. So what we are proposing now is that GABAergic receptor binding differed between, first of all, dominants and subordinates, that is, unstressed versus stressed. And by giving a CRH antagonism, we were able to actually reverse that differential GABAergic binding so that the subordinates and the dominants now had the same amount of GABAergic binding in the prefrontal cortex. So the prefrontal cortex is where you are thinking and processing stress signals. If you're already stressed, the next stress challenge that comes in may seem more stressful because you're already off balance. And essentially what happens to subordinate monkeys is what happens to many of us. They're always on guard, they're always off balance. And so the next thing that comes in elicits typically a bigger stress response. So how does this relate to humans? So if you accept the idea that psychogenic challenge and metabolic deficits synergize to disrupt GnRH drive, but that FHA, hypothalamic amenorrhea, is more than an isolated disruption of GnRH drive, then you need to come up with a treatment plan that actually cures all of the neuroaxes at once. And we know that cortisol is not so great for you, particularly when it's chronically activated. It may shorten your telomeres, alter your epigenetics, it may accelerate your aging. And just giving back sex steroids is unlikely really to reverse all the effects of stress. Don't think it's going to undo the HPA activation. We also know that if we use methodologies that we all have at our fingertips to induce ovulation and induce pregnancy, that in fact we haven't corrected the underlying hypothalamic hypothyroidism, and that may pose both obstetrical and fetal risks that I don't have time to go into today. So given that we thought that stressful attitudes, or not very helpful attitudes, promoted stress sensitivity, we decided to tackle some of those. And this is a bit of a difficult thing to explain in a foreign language for some people, but there are many ways of measuring stress. So we looked at depression. This is the Beck Depression Inventory in the Hamilton D. We looked at something, I did not invent this, but it's called Dysfunctional Attitudes Survey. Whenever I send this in to an endocrine journal, they get very mad at the name of the test, but it's a 200-item test that asks people how to problem solve, gives them challenges and asks them what they would do next, and it rates whether they chose something that was a good way of managing that stress or a not so good way. These are eating disorder inventories, and these two sub-scales are for thinness and ineffectiveness. And you will notice that we only study normal body weight women. This is a bulimia scale. And basically, what we found across many years is the following: that women who are more stress sensitive have unrealistic expectations of self and others. You can rate yourself now. They're perfectionistic and have a high need for social approval. Sound like anybody you've ever met. They're not so great at problem solving, and they don't always generate what I call lateral thinking, which is new ways of coping with old problems. They don't really have an excess of negative events, and they don't meet standard criteria for a psychiatric disorder. So addressing those attitudes, we randomize women to either the cognitive behavior therapy to focus on those, and nutrition and exercise, or observation. And what we found is that when randomized to 16 sessions over 20 weeks of cognitive behavior therapy that simply addresses some of the problem-solving techniques, that about 70% of women resumed ovulation. And those randomized to observation, just the opposite. And it looks like this. So cortisol comes down in response to the intervention. What you can see is that it takes a few cycles. These are menstrual cycles up here. This is estradiol. For the HPO to turn fully back on and become ovulatory. And those randomized to observation stayed off. And when we looked at what the impact of CBT was, we found that it reduced cortisol more or less back to normal levels. But the time of day that was attenuated was actually the nighttime compartment, and that's actually the compartment where we saw the biggest elevation. So they weren't responding to the day-to-day stressors at the moment. How many of you have ever woken up early the day before a big test or a big grant or a big challenge, ready for battle at 3 a.m.? That's when your cortisol goes up. And so what happened after treatment was that that part of the night is now restored to normal. So there's a very whopping change at night when they're actually sleeping. And that's what stress recovery looks like. You can't see it during the day. And again, there's no change in body weight, but a very big increase in leptin in response to this. Thyroid comes back on to try to correct the hypothalamic hypothyroidism. And the reasons for doing this are here, but I just want to mention one. So this is a wonderful study done by John Sidlowski's group at NIEHS, just down the road from us, looking at genes that are responsive to dexamethasone in male and female rats, and they're different. So my question is, if we have a male or female fetus and we actually help someone get pregnant who has stress as the cause, will we differentially impact the health of those offspring? There's some data from our group in Wake Forest looking at the offspring who were subjected to prednisone for preterm labor treatment, and the males pay the price. I can't go into all of it today. Shannon Werlich is now working with John Sidlowski on other mechanisms for glucocorticoids. I just want to point this one out. This is a wonderful study showing that dexamethasone antagonizes estrogen action, and so just giving back sex steroids to women who are amenorrheic on the basis of stress is probably not going to get you where you want to go, probably won't hurt, but I still recommend cognitive behavior therapy either in conjunction with other interventions or as an isolated intervention. And one of the reasons to do so is it lowers cortisol. It should restore metabolism, think leptin. It does restore their sense of control, which is great. The effect size of this intervention accrues forever. Once you teach someone to be taking care of themselves, they learn to do it better with time, not well. And I want to thank the many people who have helped me over the last 35 years to do this.